All right, so today we're going to learn about our fifth and final type of a reaction called a combustion reaction. So combustion reactions occur when an element or compound reacts with oxygen and often produces energy in the form of heat or light. Okay. So think about what you would normally think of with combustion. Okay, so something is burning, so one of the reactants has to be oxygen. So here's an example of when we combust magnesium. So magnesium plus oxygen is going to give us magnesium oxide. So when we look at combustion reactions in this class, we'll mainly focus on combustion of hydrocarbons. So first, a hydrocarbon is exactly what it sounds like in the name. So it's a molecule that's made up of hydrogen and carbon atoms. Okay, and then if it's going to combust or burn, it's going to need oxygen. So the way that you're going to identify a combustion reaction is you're going to see it's some type of hydrocarbon, okay, or some type of molecule made up of carbon and hydrogen, and it's reacting with oxygen. Okay. So that's telling you that it's going to burn. And then the products of a combustion reaction of a hydrocarbon are always going to be carbon dioxide and water. So again, when we look at these on paper, you have to be able to identify the reactants. So the reactants are a hydrocarbon and oxygen. Okay. And then the products will always just be carbon dioxide and water. So for this type, you don't have to worry about like switching places with anything or even doing formulas. You just need to remember your products are carbon dioxide and water. All right, so we're going to do two practice problems together. So we're going to combust C6H6. And so when we say we're going to combust, it's implied that you're going to react it with oxygen. And then the two products will always be carbon dioxide and water. So then now the last thing to do is just to balance it. So I'm going to start with the carbon. If there's 6 carbons on this side, I'm going to put a 6 over here. And then there's 6 hydrogens. So I'm going to put a 6, or not a 6, I'm going to make this 6, I'm going to put a 3 over here. So 3 times 2 is 6. And so now I'm going to add up all the oxygens on the right side of the reaction. So 6 times 2 is 12. And then the 3 carries over, so there's a total of 15. So I need 15 oxygens on the left side of the reaction. And so the number 7.5 times 2 gives us 15. Except, can we have 7.5 oxygens? We can't, so now I'm going to double the prefix in each of these. So it's going to become 2C6H6 plus 15O2 yields 12CO2 plus 6H2O. And then finally, the last step is just to make sure everything's balanced. So we have 2 times 6, 12 carbons, 12 carbons. 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. And then 15 times 2 is 30 oxygens. Here we have 12 times 2 is 24, and this 6 carries over for 30. Okay, here's our second example. We're going to take CH3OH and combust it. So again, combusting it implies that you're going to react it with oxygen. Okay. This time it's methanol CH3OH. Even though I added the OH, it's still a hydrocarbon. So then for products, we're still going to get CO2 and H2O. Okay, so one carbon. So now I'm going to look at the hydrogens. I have 3 and 4 hydrogens. So I'm going to put a 2 over here. So there's now 2 times 2 is 4 hydrogens. And last, we're going to count oxygens. So there's 2, and 2 is 4. And then there's 2 and 1 for 5. So since I'm at an odd number, so there's only 3 over here and 4 over here, we have an odd and an even. I'm going to try adding a 2 in front of the carbon to even it out. Okay, so now I have 2 carbons, and this side only has 1. So now I'm going to add a 2 on this side. So we have 2 carbons and 2 carbons. But now I have 2 times 3, which is 6 hydrogens. And this 2 carries over, so there's 2 hydrogens here, so 6 plus 2 is 8. So this side of the reaction has 8 hydrogens. So on this side, I need to add, instead of a 2, a 4 there. Okay, so now I have 4 times 2, so I have 8 hydrogens. And so now I have to count up the oxygens. So I have 2 oxygens here and 2 oxygens here, so 4 total. Then I have 2 times 2 is 4 and another 4, so 8 total. So in order to get this side to 8, I have 2 here that I don't want to change because it's going to affect all of my carbons and hydrogens. Okay, and I need to get to 8. So 8 minus 2 is 6, so I need this set to equal 6. So I know 3 times 2 equals 6. So now I'm going to go through and just make sure everything's balanced. So 2 carbons, 2 carbons. 2 times 3 is 6 hydrogens, plus 2 more is 8 hydrogens. 4 times 2 is 8 hydrogens. 2 oxygens, plus 3 times 2 is 6, so 8 oxygens. 2 times 2 is 4, plus 4 is 8 oxygens.